Find the value of 3 to the power of 6. Just put in 3, press the power button, which is usually x to the power of y on most calculators. So we get 729. Write 27 in the form 3 to the power of k, where k is a natural number. A natural number is a positive integer. Well, we know that 3 times 9 is 27. And we can write 9 as 3 times, well, we can write 9 as 3 times 3. 3 times 3 times 3 means 3 to the power of 3, because we have 3 of them. Or we can just add these powers. 3 means 3 to the power of 1. So we're multiplying, we just add the powers. 1 plus 1 plus 1 is 3. Find the value of x for which 27 multiplied by 3 to the power of x equals 1 over 729. Now we know that 27 can be written as a power of 3. Is it possible that 729 can be written as a power of 3? If it can, we can write everything as a power of 3. So let's look at successive powers of 3. Let's look at 3 to the power of 4. That's 81. Let's look at 3 to the power of 5. That's 243. 3 to the power of 6 gives us 729. So we can write 729 as 3 to the power of 6. So this is what we get. 27 is written as 3 to the power of 3. Now, when we multiply these two together, we can gather them into one single term because the base numbers are the same. So we get 3 to the power of 3 plus x. We add the powers. Okay, so that rule was covered in the previous video. For multiplying two terms that have the same base, we just add the powers. So we take 3 and add on x. Now what about this thing on the right hand side? Well, you would have seen in the previous video that this is 3 to the power of minus 6. 1 over 3 to the power of plus 6 is 3 to the power of minus 6. Now we've reached the stage where we just have a single term on each side. And both terms have the same base. So the only way they can equal each other is if the powers are equal. So 3 plus x must equal minus 6. And from this equation we can find x. X equals minus 6 minus 3, which is minus 9. Let's just see a check of this. I'm going to plug minus 9 back in for x here. So on the left hand side we will have 27 times 3 to the power of minus 9. We could do this on the calculator. So we have 27 multiplied by 3 to the power of minus 9. So we get this number here. So the question is this number here equal to 1 divided by 729? So just keep this in mind. 0.00137 is this number to 5 decimal places. If we take 1 and divide by 729, we do indeed get the same number. We could also invert this number by pressing this button 1 over x. This will just basically turn this upside down. If we turn it upside down, we should get 729. There it is. That's also called getting the reciprocal of this number. So 1 over this number is 729. Or if you like, 1 over 729 gives us this number, 0.00137, etc. Now we could also check this without a calculator. 27 is 3 to the power of 3, and we want to multiply by 3 to the power of minus 9. So the base numbers are the same, we add the powers. 3 plus minus 9 is minus 6. But 3 to the power of minus 6 means 1 over 3 to the power of 6. And we know that that's 1 over 729. Here are two questions from past exam papers. If 2 to the power of x plus 3 equals 4 to the power of x, find x. Now, 4 can be written as 2 to the power of 2. Why do we write it like that? Because we want base numbers to be the same. If the base numbers are the same, we can equate the powers. So you see 4 can be written as a power of 2. Now, we apply the rules that were covered in the previous video. To remove brackets, we just multiply these powers together. So we get 2 to the power of 2 times x. Now we have a single term on each side with the same base. So that means that the powers must be equal. So we get x plus 3 must equal 2x. If we solve this equation, I can bring the x over and divide by 2. So I get 3 equals x, or x equals 3. I don't have to divide by 2. If I bring the x over, I get 2x minus 1x is x. 3 equals x, or x equals 3. So let's check this. So I'm going to write this out, but I'm going to replace x with 3. So we get 2 to the power of 3 plus 3 on the left hand side. Well, that's just 2 to the power of 6. You can work that out if you like. 2 2 is 4, 2 4 is 8, 2 8 is 16, 2 16 is 32, 2 32s are 64. That's the left hand side. On the right hand side, actually, yeah, it's okay. On the right hand side, we have 4 to the power of x. Well, 4 to the power of 3 is 4 times 4, which is 16 times 4 is 64. So that checks out. If 5 to the power of x divided by 3 equals 5 to the power of 6 divided by 75, find x. Now we could multiply both sides by 3 times 75 to get rid of these denominators. Or, equivalently, we can cross multiply because we have a single fraction on each side. So we have 5 to the power of x multiplied by 75 equals 3 times 5 to the power of 6. And we can rearrange that to get 5 to the power of x equals 3 times 5 to the power of 6 divided by 75. I just divided across by the 75. Actually, I could have done that much more simply if I'd simply multiplied this equation by 3. So I'll just write it down again just to emphasize that there is a simpler way to do this. We want to get at this term. We need to get at 5 to the power of x before we can get x. So we just need to get rid of this 3. So how do we get rid of this 3? We just multiply this left hand side by 3. But if we multiply the left hand side by 3, we must multiply the right hand side by 3. So I multiply both sides by 3. So again I get 5 to the power of x on the left hand side. I multiply this by 3. So I get exactly this thing here. Now 75 can actually be written as a power of 5. 75 is actually, well actually it can't be written as a power of 5, I'm sorry. But 25 can be written as a power of 5. This can be written as 3 times 25. And the 3's cancel out. 25 can be written as 5 squared. So I can write this as 5 to the power of 6 divided by 5 to the power of 2. Then I can use rules for division. When we divide two terms that have the same base, we just take the power on top and subtract the power underneath. So we get 5 to the power of 6 minus 2, which is 5 to the power of 4. So we see that 5 to the power of x equals 5 to the power of 4. So that means that x must equal 4. So for this one, x equals 4. Evaluate 8 to the power of 1/3. Now I explained in the previous video that 8 to the power of 1 over 3 is actually the cubed root of 8. This number here is the root. You should know that the cubed root of 8 is 2, because 2 times 2 times 2 is 8. We can get the cubed root of 8 using the calculator. I could get 8 to the power of 1/3. Press the power button and put in 1/3. Now I don't have a fraction button on this calculator, so I'm going to put 1 divided by 3 in brackets. Okay, so we'll have 8 to the power of 1/3, which is 2. Alternatively, we can use this Wyatt root button, the Wyatt root of x. So on this calculator, you press 3, then you press this button here. So that means we're getting the third root or the cubed root of 8. Actually, I did that the wrong way around. On this calculator, I have to put in 8 first, then press this button, then press 2. Whoops. I should put in 8. Yeah. So in this calculator, it's backwards. But you might see a button like similar to this button on your own calculator. Actually, there is something that I forgot to mention in the last video. What if we want to calculate 8 to the power of 2/3? Well, we can write 8 to the power of 2/3 as 8 to the power of 1/3 squared. You see, we're using a rule for brackets. To go from here back to this, we just multiply 2 by a third. 2 by a third is 2/3. But 8 to the power of a third is the cubed root of 8. So we have to get the cubed root of 8 and square our answer. So we know that that's going to be 2 squared, which is 4. So you see, in general, this number here gives us the root. So if it's a 3, we're getting the cubed root. And then we put our answer to this power. Of course, we can do the entire calculation in one go on the calculator. So what we do is put in 8, press the power button, and I will put in 2/3 in brackets. 2 divided by 3. There it is, 4. Express 4 to the power of 1/4 in the form 2 to the power of k, where k is an element of q. Now q stands for the set of rational numbers. Q is the set of all numbers of the form a over b, where a and b are integers. They could be positive or negative integers. B cannot equal 0. That's the only thing. So the set Q includes all the integers, because we can write an integer like 10 as 10 over 1. See, we can write it in the form a over b, where a and b are both integers. Or something, or we could have something like -7 can be written as -7 over 1. So Q includes the set of integers. But it obviously includes things that are not integers. It includes things like 2 over 3. You can see that 2 is an integer, 3 is an integer. 2/3 has this form, so 2/3 is an element of Q. Now, we want to write it in the 4 to the quarter in the form 2 to the power of k. So we write 4 as a power of 2. That can be done. 4 is 2 squared. Now, that can be done quite easily. Obviously, if we were given, say, 5 to the power of a quarter, we would not be able to do this without a calculator. So, we get a number like 4. We could have got a number like 8. 8 can be written as 2 to the power of 3, or 16, so on. It has to be fairly clear. So 4 is 2 squared, and we have to put that to the power of a quarter. And now we can use our rules for brackets. We just multiply these powers together. 2 times a quarter is a half. So that's it. We've written 4 to the power of a quarter in the form 2 to the power of k. This is in the form 2 to the power of k. You can see what k actually is. K is actually a half, although you don't have to explicitly state the value of k. It's clearly a rational number. It's an element of Q. In part 3, we want to solve for x the equation 8 to the power of 1/3 times 4 to the power of a quarter equals 2 to the power of 5 minus x. Now, when solving equations where x is a power, we try to get all the base numbers the same. Okay, you can see that these base numbers are different, but we know that we can write them all as powers of 2. So we write 8 as 2 to the power of 3. As a matter of fact, we've already worked out 8 to the power of 1/3, so I don't have to do that. I could actually do it like, 2 to the power of 3 to the power of a third, then multiply these powers together. 3 by a third is 1, so we get 2 to the power of 1 is 2. That was the answer to part 1, actually. I could have worked out part 1 by doing it this way. Right, 8 is a power of 3, and so on. Anyway, that's just, getting the cubed root of 8. So we have that. So that's 2. 2 or 2 to the power of 1. 4 to the power of a quarter, we have already. We know it's 2 to the power of a half. and the right hand side is 2 to the power of 5 minus x. So now we want to get a single term on each side. So we multiply these two terms together. The bases are the same, so we just add the powers. We get 2 to the power of 1 plus a half. 1 plus a half is 1 and a half. Or if you like, 3 over 2. And on the right hand side, we have 2 to the power of 5 minus x. Now we have a single term on each side. The base numbers are the same, so the powers must be the same. So we must have that 5 minus x equals 1 and a half. So minus x equals 1 and a half minus 5, which is minus 3 and a half. Change the signs on either side. We get that x equals 3 and a half.